Okay, let's give you guys some more practice. So given this random graph here, what is the acceleration at time equals 3? Okay, so press pause and have a go. Okay, so in your mind, try and visualize the three graphs. You've got your acceleration time graph, you've got your speed time graph, you've got your distance time graph. I've given you speed time graph, so I've given you this one here. So remember the speed time graph, the gradient of the speed time graph represents the acceleration, and the area of the speed time graph represents the distance. So the middle graph here, the speed time graph, is the most useful of the three graphs. Okay, well, I've given you the middle one here, the speed time graph. So I've given you the middle one. Now you want to know the acceleration. So I've given you the middle one. If you want to know the acceleration, then you've got to look at the gradient. Okay, so the gradient of the speed time graph represents the acceleration. Okay, so here you want to know the acceleration at time equals 3. So time equals 3. It's right here. What is the gradient at this point here? Well, the gradient at time 3 is the same as the gradient at time 2. That's the same gradient as of time 1. So basically, work out the gradient of this line. Well, let's use this triangle here. So the gradient would be the up and down here, which is 1, divided by the across here, which is 5. Okay, well the gradient here would be 1 over 5. So the acceleration is 1 over 5 meters per second squared. Okay, so next one. Given this random graph here, what is the acceleration at time equals 2? Okay, so press pause and have a go. Okay, so remember, if you have a car that's accelerating, let's say it's accelerating at, let's say, 3 meters per second squared. This one here is accelerating. Let's say you've got another car here that is not accelerating. Let's say it's traveling at a constant speed of 7 meters per second. Okay, so this one here is accelerating. So oops, hang on. This one here is accelerating. So the acceleration time graph for this car here will be 3. The speed time graph for this car here will look like this, and then the distance time graph for this car here will look something like this. Okay, it will be some sort of quadratic. For this one going at a constant speed, it will be the acceleration here will be the acceleration here will be 0. The speed time graph here will be horizontal. Looking at this is horizontal. Over here, the speed here is diagonal. Okay, and then the distance time graph will be a straight line. The distance time graph for this car here will be, in a way, a quadratic. Well, if you look at this, the acceleration at time equals 3. At time equals 2. At time equals 2 is a straight line. You see, this here is a straight line. This is, in a way, a quadratic. So therefore, you know that this car must be going at a constant speed. If it's going, well, there's no acceleration. When you have a distance time graph that's like a straight line here, then you know the car is not really accelerating. If you have a sort of a quadratic graph, the distance time graph happens to be, in a way, a quadratic, then you know the car is accelerating. So this car here is not really accelerating because it's a straight line. So the acceleration must be 0 here. So overall, the acceleration is 0 meters per second squared. Okay. Next one. Given this random graph here, what is the distance traveled between t equals 9, between 9 seconds and 11 seconds? So press pause and have a go. Okay, so to do this here, remember in your mind, picture the acceleration time graph, speed time graph, and then you've got your distance time graph. This graph here is the most useful, and is the one that was Yeah, that was given. So remember, the gradient of the speed time graph represents the acceleration. If you want to know the distance, then the area underneath the speed time graph represents the distance traveled. Well, here, what is the distance traveled between 9 and 11? So what is the, well, it's the, you've been given a speed time graph. You've been given this graph here. So the area underneath the graph represents the distance traveled. So, and if you think about it, what's been given to you is speed time graph. So you can imagine it as being a car, the speed of the car, because this graph is speed time. So the speed of the car is 5. You can see that here. The speed of the car is 5 at this point here and this point here. Well, the car's going at 5 meters per second at 9, 5 meters per second at 10, 5 meters per second. Well, the car's traveling at constant speed. It's moving 5 meters per second every second. Well, the area underneath the graph here represents the distance traveled. So this one here would be 5 for the height here, and then times 2. So it would be 10. Okay, so the distance traveled between here and here is 10 meters. Okay. Anyway, next one, random graph here. What is the speed at time equals 1? Okay, so press pause and have a go. Okay, so picture the 3 graphs in your mind: acceleration time graph, speed time graph, and distance time graph. The gradient of this represents the speed. The gradient of the speed time graph represents the acceleration. Well, here I've given you this one here, and I want to know the speed. Well, the speed, well, remember the gradient of this represents the speed. Well, the gradient of this is, so it's really you wanting to know the gradient at this point here. Okay, so you can use any triangle. You can use this one here, or you can use this one here. Okay. Well, the speed at time equals 1 will be, let's say, 4 over 2. 4 over 2. That's 2. So the speed is 2 meters per second. Sorry, 2 meters per second. Okay.